Today we're going to study something called piecewise functions, which is basically where you have a graph that's made up of multiple functions, but each function is only there as a piece. So it's not the entire function, it's just a piece of a function, and you can have 2 or 3 or 4 or 5 or however many you want. So if you look at the first page of this worksheet, the first question asks, does this graph represent a function? So if you look at that graph, is it a function? Well, you need to remember, in order to be a function, so these are my x's and these are my y's, every x is only allowed to hit one y. So that would make a function. Okay? But if one of these x's is actually connected to 2 different y's, so let me back up just a little bit, make that a little less confusing. That is still a function, because every x is connected to one y. It's okay if certain y's get hit more than once, that's fine. The only thing that can't happen is this. No x is allowed to touch 2 y's. So if I had the numbers, let's say 5 was matched with 2 and 3, 5 cannot belong to 2 and to 3 at the same time. And if you look at that on a graph, 5, 2 is right there, and 5, 3 is right there. Whenever you have 2 points that are right above each other, that makes it not a function. So we've created this thing called the vertical line test. If you take a vertical line, and I'm missing a marker. So if you take a vertical line and you move it around on the graph, does it ever hit more than once? No. It only ever hits one time, and that's called passing the vertical line test, and if it passes the vertical line test, then the graph is a function. If you were to graph, say, a circle, that would fail the vertical line test because it hits twice, which means there's an x value that has 2 different y values. So the first one, yes, it's a function. Why? Because it passes the vertical line. So that's the answer to the first question. Is it a function? Yes. How do we know? Because it passes the vertical line test. All right. So this graph is representative of this story. Mr. White has decided to try his hand at business. Since nobody of any intelligence tried to talk him out of it, he went ahead with his plans. Below is a chart modeling the amount the company was worth in thousands for the first 24 years. So you can see my company did really well to begin with, and then it lost a whole bunch of money, and then it gained back a whole bunch of money, and then it started losing money again. But if you look at this, there are actually 3 different functions inside there. The first function, well, let's answer the questions first. The second question says, when should Mr. White have sold the company? When was the best time to sell it? $16 or $8, which would have been better? I would prefer 8. They're both worth the same amount of money. When x is 16 and when x is 8, they're worth the same amount of money. Why would 8 be a better choice? Well, you're going to get it all back. So this point and that point are at the same height. Yeah, why wait 8 more years to not make any additional money? Well, and then there's always the fact that maybe your heart isn't going to survive that. I don't know. I mean, if I told you, hey, you have your choice. You'll have $32,000 8 years from now, or you'll have that same $32,000 16 years from now. What are you going to pick? Oh, yeah, 16 years, right. Okay. But, so, I mean, that question's up for debate. Whatever you pick is what I would pick 8. Because then you work half the time for the same amount of money. All right, next question. when would have been the worst time to sell the company? 12. Or 24 is really close to 0. Is 24, it never hit 0, but wouldn't it be bad to go to like year 40? Because you put 40 years in, and how much is it going to be worth by the time you get to 40? I don't know, like 35 cents? Not very much, if that. So whatever you put for that is okay. Whatever you decide. And then what sort of patterns do you see in the graph? Well, this first piece looks like what type of function? Linear. And then this second piece looks like what type of function? What type of function graphs a parabola? An x squared, which is a quadratic function. And then what type of function goes down really fast and then gets closer and closer and closer to 0? Starts with an E, exponential. So that question, you see 3 different patterns. The graph looks like it's linear, it looks like it's quadratic, and it looks like it's exponential. Okay? Well, you cannot look at a graph and say, oh, it looks linear, therefore it's linear. Or it looks like a quadratic, therefore it's quadratic. Because you can basically make a lot of these equations look like any of the other equations. The only way to totally verify it is by looking at the numbers. So if I look at the table of values here, if something is linear, it changes by the same amount every year. Every year we make the same change. So from year 0 to year 1, how much money did the company make? 3, and it's really 3,000, right? So plus 3. What about the next year? Plus 3, plus 3, plus 3, plus 3, plus 3, plus 3, and plus 3. So is that linear? Yes, because it has a constant first difference. So that question asks, what sort of pattern do you see in the chart? For the first 8 years, it goes up by 3 every year. So for the first 8 years, it is linear. And you can see that on the graph. For those first 8 years, we have a straight line. Then it changes. Anybody remember how to tell if an equation is quadratic by looking at the table of values? Well, let's look at the differences. So we went, at year 8, we had $32,000, and then it drops to $18,000. How much money did the company lose? $14,000. So this is minus 14. How much did it lose the next year? Minus 10. And then how much did it lose? Minus 6, and then minus 2. And once the company hits $0, what happens? It adds 2. So plus 2, and then plus 6, plus 10, and plus 14, and then we've reached $32,000 again. Well, looking at the first differences, is this a linear equation? No. If it was linear, then all of those first differences would be the same. How do we check to see if it's a quadratic? Anybody remember that? It's not the first difference, it's the second difference. So we take those green numbers that I just wrote, and I do it again. If we're at negative 14, and a year later we're at negative 10, how much did we change by? Plus 4 or minus 4? Plus 4. So the second difference is plus 4. And from negative 10 to negative 6 is also plus 4. What about from negative 2 to 2? plus 4, and it turns out all of those are the same. So what pattern do you see in the numbers? A constant second difference. And whenever you have a constant second difference, then the equation will be an x squared. Okay? So from here to here is quadratic. What does it mean for something to be exponential? In this case, it's going to get close to hitting 0. So multiply. You multiply by the same number every time. So if we look at 32, what do I multiply 32 by to get 16? 32 times what is 16? 32 times 4 would be like 128. 1/2, right? 32 times 0.5 is 16. So this is times 0.5. 16 times what is 8? 8 times 2 is 16, but 16 times what is 8? Times by 0.5 again. 8 times what is 4? So it turns out all of these are multiplied by 0.5. And that makes it exponential. Okay? All right, pull out your calculators. We are going to use our calculators to figure out what the equations of each of these are. All right. So we know that these numbers are linear, those numbers are quadratic, and those numbers are exponential. So we're going to plug numbers into our calculator to figure out what the equations are, and then we can write what is called a piecewise function. And one thing you have to remember is, if it's linear, you only need 2 points. If it's quadratic, you actually need 3 points. And if it's exponential, you only need 2 points. So, everybody push stat, and then edit, and clear out whatever is there. And remember, you always push clear, don't push delete. If you push delete, you'll just eliminate the list. So for a linear equation, I need 2 points. Any 2 points will work as long as it's in that section that represents linear. So I'm going to use 0, 8, and 1, 11. So I put 0 and 1 into L1. That's my X list. And I put 8 and 11 into my L2. That's my Y list. Anybody need help sticking those in? So once you have the points entered, we want to create what is called a linear regression. Regression just means the calculator will give us an equation if we tell it some points. So everybody push stat, and then go over to calc, and number 4 says linear regression. So push number 4, and I just have to hit enter. Some of you have to go down to calculate and hit enter. So we get the equation ax plus b, where a is 3 and b is x. So it's y equals 3x plus 8. You didn't get it? Did you put your numbers in wrong? Oh, yeah, that'll do it. Okay, now let's find the quadratic equation. So go back into stat, edit, and this time we're going to use the first 3 points of the quadratic. So stat edit, and my x's will be 8 and 9 and 10. And then my y values are going to be 32, 18, and 8. Now this time, we're not using the linear regression. We want to figure out the quadratic equation. Now, if you happen to type linear regression, it will give you an answer, but the answer will be totally wrong, and it won't even hit all 3 points. It'll just kind of be an estimation. So this time you push stat, and you go to calc, and quadratic regression is number 5. Now don't get that mixed up with number 7. 7 is quartic, which means x to the 4th. 5 is quadratic, which means x squared. So I hit 5, enter, and so now it gives me a, b, and c. So my quadratic equation is 2x squared minus 48x plus 288. Now I need to go back into stat, edit, and put in 2 points for the exponential equation. And any 2 points will work, but I'll just pick the first 2. For linear and exponential, you only need 2 points. For quadratic, you need 3. So I'm going to go back into stat, edit. I'm going to clear out my lists and put in 16 and 17 and 32 and 16. So this time we're going to run a exponential regression. So you go into stat and calc, and you can't see exponential regression until you go all the way to the bottom. And I believe it's number 0. Yeah, 0 is exponential regression. Hit enter. And it says a times b raised to the x power. So it's y equals 2097152 times 0.5 raised to the x. And that's the equation for that final piece. Now here's where it gets a little bit tricky. We need to combine all 3 of these into one function. So this is the last question. If you look down at the bottom, it says write a piecewise function representing the value of the company. So the company sometimes looks like this, and sometimes it looks like that, and sometimes it looks like that, but it never looks like all 3 of them at the same time. So here's how you write a piecewise function, and leave yourself a little bit of room. So you write f of x equals, and then you write this big parenthesis. That it kind of looks, it's called a set notation parenthesis. It looks kind of funny. And then you list all 3 equations according to which one happens first. So if you look at the graph, which function do we see first? The linear. So I write 3x plus 8. Which function happens second? The quadratic. So 2x squared minus 48x plus 288. And then the exponential happens last. So 2097152 times 0.5 raised to the x. So that's the first half. What are you doing? Can you move forward, Justin? Poor Gus he's in a car wreck. Okay, so piecewise functions have to have the domains listed. So we have all 3 of these functions, but we need some way to say when each function exists. Okay, so in addition to the function off to the side, you need to write less than x and less than on all of them. less than x less than x less than. And we put when the function starts and when the function stops for each piece. And it will always look like this. Something less than x less than something else. Okay? So for the linear piece, what is the smallest number that the linear piece equals? What's the smallest x value? Smallest x value? 0. So we put a 0 here. And then we have to decide, is 0 less than x or is it less than and equal to x? Is 0 part of the linear function? Yes. So we put an equal to there, which is the same thing as a bracket. Okay? And then how big does the linear function get on the x-axis? To 8. Well, is 8 part of the linear function? Yes, so we put an equal to. All right, what is the smallest piece of the quadratic function? What is the smallest x value for the quadratic? How low does the quadratic function go? This is on the x-axis. What is the smallest year that the quadratic function exists? 8. Right? So the linear function starts at 0 and ends at 8. The quadratic function starts at 8 and ends at 16. So 8. Now this is kind of tough. Sorry, where are you confused, Dylan? Where are you confused? Oh, okay. So this is a little bit tricky. Can 8 belong to both the quadratic and the linear? And the answer is no. We have to pick one or the other. Now in this case it doesn't matter which one we pick, but we put the equal to on top, so on bottom there won't be an equal to. So then, when does the quadratic function stop? At 16. And 16 is also where the exponential begins, but does 16 belong to the quadratic or the exponential? Either one. We don't know. It doesn't matter. So one of them has to have an equal to, but it doesn't matter which one you give it to. So we could put it there. And then how long does the exponential last? Well, the table of values stops at 24, but it's probably going to go forever onto infinity. And that's a piecewise function. You state what the function is, and then you state the x values when it counts. Then you go down to the next line. State the function, state the x values. State the function, state the x values. Okay? So turn the paper. Here is another piecewise function, and we're going to go through each of the answers for this function. So, the first function is linear, and it only exists -5 less than or equal to x to less than or equal to -2, and so on. So, these first questions here asks, what is the y value when the x value is -4? So if I go to x equals -4, what is the y value? Close, not 1, it's -1. So if I go over here to -4 and down to -1, so when f, what is f of -4? Well, the answer is -1. What happens when we plug in -2? Goes to -3. What happens when what is f of 2? Now, f of 2 is a little confusing Is it going to be -3, or is it going to be 1, or is it both? Can't be both. If it's both, then it would fail the vertical line test, right? So what does an open circle mean? Nope. Open circle means it doesn't count. Closed circle means it does count. So f of 2 is actually 1. Because it does not hit there, but it does hit there, so f of 2 would be 1. What is f of 0? 1. You plug in 0, you get 1. Okay. What is the domain of this graph? So if I draw a line through the x-axis, are there any times where this line does not hit the graph? Does it hit over here? Does it hit right in here? Oh. Does it hit over here? Does it hit over here? So what is the smallest number that that line hits? -5. Does it actually hit -5, or does it miss -5 and hit everything bigger? So at -5, does it hit the graph? Yes, because that is a closed circle. So the domain is going to be bracket -5. And then does it hit all of these? What about 2? Does it hit at 2? Well, it misses the bottom, but it does hit the top, so that's still okay. When does it stop hitting? That's where it stops hitting. Does it actually hit when x equals 4? Yes, because it's a closed circle. So -5 to 4 is the domain. What about the range? So now we draw a line through the y-axis. Let me rotate this. Does this always hit, or does it miss sometimes? It misses. So what's the smallest number that it hits? So it hits down here at -3. And what's the last number it hits? 3. So the range would be -3 to 3. Does it actually hit at -3? Wait a minute, that's an open circle. Oh, but the other side is a closed circle, so it does hit. So that gets a bracket. At +3, does it hit? Yes, so that's also a bracket. All right, maximum. What is the biggest number this graph reaches? X equals 3. What's the smallest number? -3. And notice the maximum and the minimum are shown in the range. Well, the lowest number in the range is the minimum, and the highest number in the range is the maximum. Okay. X-intercepts. How many x-intercepts does this have? It has 3 x-intercepts. What are they? -5, -1, and 1. How many y-intercepts does it have? Just 1, and it is y equals 1. Now, increasing is a little bit tricky. It's increasing from here to here. It's also increasing from here to here, but then it goes flat. And then it increases from there to there again. Okay, go ahead. So, how do you describe that piece? What are the x values for when the graph is going up? No, we're looking at the x's, not the y's. So from -2 until 0. If you're driving a car on that graph, is the car going up when x is -2? If you're parked right here, is the car facing up the hill? Well, it goes like this, and then it goes like that. So you're stuck inside there, but we have to look at the domain. If you look at the domains, -2 is actually part of the linear, not the quadratic. So this would be parenthesis. At 0, is the car facing up the hill? No. Okay, we'll union that with, how do you describe the red piece? From 2 to 3, if you're parked at 2, is the car facing up the hill? Yes, so it gets a bracket. If you're parked at 3, is the car facing up the hill? No. Parenthesis. Union with this last piece. 3 gets a parenthesis, and 4 gets a bracket. Okay? And then we're decreasing from here to here and from here to here. So decreasing would be from -5 to 2. Is the car going down at -5? Yes. So it gets a bracket. Is the car going down at -2? Well, if we look at the domains, -2 is part of the linear. So -2 belongs to the linear, not the quadratic. So at -2, it would be facing down the hill. And then it's also decreasing on this piece from 0 to 2. At x equals 0, is the car going down the hill? So if you're parked right here, is the car going down the hill? No. Okay. If you're parked right here, is the car going down the hill? Yeah, but you can't park there. Because if you look at the graph, it's actually an open circle. So there is no place there to park. So that would be a parenthesis. Okay. Now I'm going to teach you how to graph these, and this is kind of confusing. Okay? You can graph piecewise functions in your calculator. Here's how you do it. You put the first one in y1, and the second one in y2, and the third one in y3, but there's a catch. You have to put the graph in parentheses. And then you have to put the domain in parentheses, but you have to break it into 2 different parentheses. So it'd be -5 less than or equal to x and less than or equal to -2. Or wait, and then the second one would be x less than or equal to -2. So follow along carefully. Go into y equals. In y1, write parenthesis -x minus 5 parenthesis. Everybody got that? So now we break this domain into 2 pieces. So the first one is parenthesis -5, and you find the inequalities in second math, where it says test. So second math, and the first one is less than or equal to x. Then close the parenthesis, and then open another parenthesis and put the second half of the domain. X less than or equal to -2. Anybody having trouble with that? All right, so now you need to do the same thing with the other 2 graphs. So go down to y2, type in the function, -x squared plus 1, and then you break up that domain into 2 pieces. -2 less than or equal to x, parenthesis, oh wait, it's not less than or equal. The squared button's right here. So this one is actually just strictly less than. And then x less than 2. And then go down to y3 for the next graph. Parenthesis, x minus 3 to the third plus 2. And then that domain. So was your question here, Gretchen? So for that last one, you actually need 2 sets of parentheses. One around the whole thing and one around the x minus 3. Oh. Sorry. 2 less than or equal to x. Oh, shoot. And then x less than or equal to 4. And now, when I graph it, oh, I need to change my window. So you should see those pieces. Now, hold on a second. Hold on. On some of your calculators, it's going to graph, and then it will draw a line to the x-axis. Ignore that line. And then it will draw a line to the x-axis there. Ignore that line. If you have an older calculator, it will draw those lines. Okay, go ahead and hand that in.